Hi everyone, and welcome to the Chapter 4 and 7 Lipids Vocabulary List. So I pulled from these from chapters 4 and 7, which is where the textbook discusses fatty acids and lipids. So the first vocab term is fatty acids. Fatty acids are chemicals that consist of a long hydrocarbon tail that's made up of carbons and hydrogens with a carboxylic acid functional group at the end. A lipid is technically any molecule that is not soluble in water, and we divide the lipids typically into fats and oils, and there's lots of different types of chemicals that are classified as lipids. The three that we go over are the triglycerides, the phospholipids, and the sterols. Those are all types of lipids. There are other classes of lipids that we don't get into. Monounsaturated is referring to a fatty acid that has one double bond. So unsaturated fatty acids have double bonds. Saturated fatty acids have all single bonds between the carbons. So a monounsaturated fatty acid has one double bond. A polyunsaturated fatty acid has two or more double bonds in that hydrocarbon chain. In an unsaturated fatty acid, the omega number is the number of carbons away from the end of that chain where the double bonds start. And it's indicated in the carbon designation with a little W-looking symbol. That's actually the Greek letter omega, so it'll be omega-3 or omega-6. Amphipathic is a term that means that a molecule is both polar and unpolar. So it has a very polar electronegative end and a nonpolar end. So fatty acids are examples of amphipathic molecules. Phospholipids are really good examples of amphipathic molecules. The phosphate group is negatively charged, so it's very hydrophilic. It's attracted to water. And the hydrocarbon tail is very hydrophobic and nonpolar. It's afraid of water because it's not polar. So that an amphipathic molecule, amphipathic means having both a polar and nonpolar, or hydrophilic and hydrophobic areas. So again, hydrophilic means water-loving, and hydrophobic means water-fearing. An emulsifier is something that is amphipathic, and its function is to help dissolve nonpolar things in polar solvents. So bile salts are a classic example of an emulsifier. They help to dissolve dietary fat in the intestines. They help to emulsify it, to break it up into smaller bits and help it suspend in smaller parts in the aqueous solution that is our digestive juice. Esterification is the process of forming an ester bond. When a fatty acid and a glycerol get together, they form an ester bond. So a triglyceride is a glycerol with three fatty acids that are connected by three ester bonds. So the process of building triglycerides is technically esterification. A fat is a lipid that is typically solid at room temperature versus an oil, which is a lipid which is typically liquid at room temperature. So oils have lower melting points than fats. The fluid mosaic model is the representation of the cell membrane. So it is fluid in that it's made up of phospholipids that are loosely connected. So it's flexible and fluid. And it's a mosaic, meaning there's lots of different proteins and oligosaccharides embedded in or sticking off of the membrane, so it looks like a mosaic, like a randomly ordered pattern. Hydrogenation is the process of adding hydrogen to molecules to do a chemical reaction where you add hydrogen. In the case of fatty acids, hydrogenation turns unsaturated fatty acids into saturated or trans fats. A micelle is a structure, a spherical structure that amphipathic molecules can form when put in solution. So like phospholipids, when you put them in water, will automatically form this sphere called a micelle, where the polar heads are on the outside and the nonpolar tails are on the inside. Soap does this as well. Phospholipids are a type of lipid that make up our cell membranes, and they are made up of a glycerol and 2 fatty acids and then a phosphate group, a charged phosphate group. Steroids or sterols are another class of lipid. The sort of poster child of the sterols is cholesterol. Cholesterol is a precursor for a lot of different sterol lipids, including testosterone, different sex hormones, bile salts. So a steroid, the key feature of the steroid is the steroid nucleus. So it's a 4-ring carbon ring structure that looks kind of like a piece of honeycomb, and that is the foundational chemical structure of all the steroids or sterols. And then lastly, triglyceride is a type of lipid. It's the one that's found most abundantly in our diet, so we use it for energy storage. And it is made up of a glycerol and 3 fatty acids, which is why it's called a triglyceride. The end.